So we have a tire salesman claiming that the tires he sells have an average lifespan of 28,000 miles. A trucking company is suspicious of that. They put 20 of the tires on their trucks and they get a mean life of 27,563 miles. And the standard deviation is 1,348 miles. Okay, we're going to test this at an alpha level of 0.01. So, traditional method. First step we need to do is state our hypotheses. So, H, our null hypothesis, is that the tires have an average lifespan of 28,000 miles. Okay, the alternative hypothesis, in this case, what the truck company is wondering is, do these really get 28,000 miles, or is it less than that? If it's more than 28,000 miles, they don't care. That means at least 28,000. They're looking at, are they going to be less than 28,000 miles? Okay, so there are our two hypotheses. Okay, let's write down a little bit more of the information we know. Okay, we know that the mean of their sample mean X bar, is 27,563. Okay, this is a standard deviation of their sample, so it is S. It is the sample standard deviation. Another piece of data that we know is that N equals 20. Okay, we're going to say that this is the claim. This is what the tire salesman is claiming, and then the truck company wants to see, is this really true or not? Okay, so with our traditional method, we have our hypotheses. Now we need to find the critical value and draw the critical region. Find critical value, draw critical region. Okay, so to find our critical value, first we're going to have to know, is this a z-test or a t-test? Well, we can see we have our sample standard deviation, so we are going to do a t-test. We'll need table F, our t-distribution. Okay, now one thing we'll notice here is we need the degrees of freedom number. Okay. How do you find the degrees of freedom? Degrees of freedom is n minus 1. So in this case, it is 19. We have 19 degrees of freedom. Okay, so now we're ready to go to our t-distribution table. We need to know a couple other things. First of all, is this a one-tail or a two-tail test? Well, we're looking at mu being less than 28,000, so it's one tail. It is a left tail test. Okay, we need to know our alpha level. There's alpha, 0.01. And we have our degrees of freedom. So we're ready to go ahead and find that critical value. Okay, so we have alpha, we have one tail test with alpha of 0.01. So we're going to be in this column right here, and we're going to go down to 19 degrees of freedom, which is right here at 2.539. Okay. So when we draw this out, okay, we know this is left tail, so it's negative 2.539 for that critical value. So this is our critical region right there. All right, once we have that, the next step is to calculate our test value or our test statistic. Calculate test value. Okay, you need your formula for that. T equals X bar minus mu divided by, this is S, remember it's sample standard deviation, divided by square root of n. Not degrees of freedom, but the sample size. Okay, so for this problem, we have t equals our x bar 27563 minus mu divided by 1348, our sample standard deviation divided by square root of 20. Okay, and when you calculate that out, we get a value of negative 1.45. Okay, so that's our test value. So we take that test value and see, where does it fall? Where does it fall? Well, it falls in here somewhere. Okay, it falls right in that area. So it is not in the critical region. So now you have to make your decision based on the test statistic not being in the critical region. And your decision for that is to fail to reject HO. Okay, so we fail to reject HO means we keep this HO, that the mean of these tires is 28,000 miles. Okay, and so what are our conclusions? Our conclusion is there is not enough evidence to dispute the tire salesman's claim. And there is our hypothesis test.